Hi everyone, I am Keshav Vishwas and my teammates are Harshita Jay Shai Shankar. We are from third year of Bachelor Technology, Rajiv Gandhi University of Knowledge and Technologies, Ongole IIIT. We have done internship in EMERTXE Information Technologies during last month. These are the contents we are gonna see in the presentation, the topics learned during the internship. What is a washing machine and its requirements, and what is microcontroller and microprocessor? About PICSIMLAB, MPLAB, XIDE, XE8 compiler, hardware peripherals, and lastly project implementation. These are the topics learned during the internship. Introduction to C language, arrays and pointers, functional strings, storage classes, conditional loops and operation, and introduction to embedded systems, microcontrollers, MPLAB, XIDE, XE8, PICSIMLAB, peripherals of 16F877A. And these are the requirements of MPLAB, XIDE, X8 compiler, PICSIMLAB, PIC16F877A, 16 into 4 CLCD, buzzer, fan, switches. Coming to this part, in today's world, household appliances help make daily tasks easier and reduce physical effort. They also improve overall productivity at home. Technology, especially microcontrollers, has made washing machines smarter and more efficient. Modern washing machines are now energy saving and user friendly. The project uses the PIC16F877A microcontroller to develop a smart washing machine system. Coming to this slide, we can see this what is embedded C. An embedded C is a version of programming language used for programming embedded systems. These systems are typically devices with dedicated functions such as microcontrollers, microprocessors, and digital signal process DSPs. And embedded systems are often found in devices like home appliances, cars, medical equipment, and industrial machines. This is the syntax of the embedded C. And coming to this slide, in this slide we can see what is microcontroller and what is microprocessor. A microcontroller is a small computer on a chip. It controls devices like appliances and toys. It has a CPU, memory, and input output pins built in. It can work on its own to control simple devices. And coming to microprocessor, a microprocessor is the main part of the computer that does all the thinking. It needs extra parts like memory and input output devices to work. It is used in bigger systems like computers and smartphones. These are the architectures of microprocessor and microcontroller. In microprocessor, there is a three parts are there. One is arithmetic logic unit, and second one is control unit, and third one is registers. With this, to communicate with the system, there is a address bus and a data bus and control buses are there. And coming to microcontroller, in microcontroller there is a six parts are there. One is CPU, and second one is input output ports, and third one is counters, and the fourth one is timers, and fifth one is RAM, and sixth one is ROM. It has three buses are there. One is address bus and data bus, and third one is control bus. These buses are bidirectional flow with data. And coming to this slide, embedded system. What is embedded system? An embedded system is a small computer system designed to do a specific task. It has so many features are there: high stable, time specific, low cost, minimal interface, limited memory, less power, fault tolerance, high efficiency, real time operations, and reliable. It includes a processor, memory, input output devices. It works as a part of a larger machine or electronic system. And it has some applications are there like digital watches, cameras, gadgets, healthcare devices, agriculture tools, industrial machines. And coming to this slide, the embedded systems are divided into two parts based on performance and functional requirements, and second one is based on performance of the microcontroller. And coming to first one, these are divided into four subdivisional topics. First one is real time, and second one is standalone, and third one is network, and fourth one is mobile embedded systems. And coming to second one, small scale and medium scale and sophisticated. A small scale, the size is about 16 bit, and coming to medium scale, it varies the size of 32 bit, and last one sophisticated. It is very large and complex. It varies the size of 64 bit. The main purpose of project is the project simulates a washing machine using PICSIMLAB. It works like a real washing machine but on a computer. First it studies washing machine parts and how they work. It looks at settings like fabric type, load size and water level. This project is main aim to replicate real world washing machine functionally. This slide tells about PICSIMLAB. The main tool is used in the simulation is PICSIMLAB. A PICSIMLAB is a tool to test PIC microcontroller. It helps test things like motors and lights without real hardware. It's useful for learning and testing embedded systems virtually.
Good morning everyone, I am Harshita and I will be explaining the core components that made our washing machine project possible, especially the simulation tools, the PIC microcontroller, hardware peripherals, and the system logic. Let's begin with the simulation platform. In this slide, we'll discuss about PICSIMLAB. We use a PICSIMLAB, which is an open source simulator for PIC microcontrollers. It allowed us to build, test, and debug our washing machine virtually without needing real hardware components. For example, instead of physical connecting an LCD or motor, PICSIMLab provides virtual buttons, LEDs, buzzers, and LCDs. This helped us learn how actual hardware behaves by just uploading the hex file. It also reduced the risk of damaging components during testing, making it perfect for beginners in embedded systems. And in this slide, pick 16F877A microcontroller. The brain of our washing machine system is the PIC16F877A, which is an 8-bit microcontroller from Microchip Technology. It contains 14 KB flash memory for storing the program, 368 bytes of RAM, 256 bytes of EEPROM. And it runs at 20 MHz, operates typically at 5 volts, and supports lower power modes. For example, we used its digital I/O pins to connect the tactile switches and LCD, and timers to control the wash cycle duration. One reason we choose this MCU is its compatibility with MPLAB tools and easy of simulation in PICSIMLAB. And the next slide was software requirements. The software tools we used were MPLAB X IDE. It's an integrated development environment that helps write, compile, and debug code efficiently. X8 compiler, a powerful C compiler that translates high-level code into efficient machine-level instructions for PIC16F877A microcontroller. For example, in MPLAB-X, we wrote the main logic to simulate door control, wash, start, stop, and LCD output. Then we compiled it with XC8 and observed the output in PICSIMLAB, just like how a real system works. And the next component was CLCD. We used a 16 into 4 CLCD in PICSIMLAB. The LCD displays messages like washing started, rinsing, or completed. It gives visual feedback to the user and makes the system more interactive. It was connected to port D of the PIC tactile switch. Tactile switches act like buttons. We use them as user input, such as selecting modes, starting, pausing, or stopping the washing page. For instance, if you press one switch, it might trigger quick wash and another for rinse. The microcontroller detects the logic level from pressed switch and responds accordingly. And coming to the next slide, interrupts. Interrupts allow the microcontroller to pause the current task and give priority to urgent inputs. We used interrupts in our simulation to mimic real safety mechanisms. For example, stopping the motor when the washing machine door is opened during operation. PIC uses ISR, means interrupt service routines, to manage these events. In this slide, we discuss about timers. PIC16FA77A has three timers. Timer 0, which is 8-bit, timer 1, it is 16-bit, and timer 2, 8-bit. We use these timers to control how long each washing stage should run. For example, a timer can control the spin cycle for 30 seconds, then move to rinse after a delay. They are very important in time-based tasks. And the next, keypads. The keypads was used to take user input in binary format. There are two types of triggering used. First, level triggered and edge triggered. We explored both. The two wiring types used are sourcing circuit. In this, 1 means on, 0 means off. Syncing circuit. In this also, 1 means off, 0 means on. In our case, each button presses selected a wash mode or sent a command to start the process. And the next slide was buzzer and fan. The buzzer gives audio feedback used to alert the user at the end of the washing cycle. It beeps for 2 seconds after completion. The fan acts as the washing machine's motor. When any mode is selected, the fan spins if the door is opened. Detected by any condition, the fan stops and resumes when the door is closed. This simulates the real-time motor control logic. And this is the slide for explaining the block diagram. This is the system's block diagram showing how every component is connected to the microcontroller. The input devices like tactile switches and keypad are connected to port B. The output devices like LCD, buzzer, and fan are connected to other ports. The microcontroller is in the center, controlling and managing all the actions. So this structure represents a closed-loop embedded control system where user input leads to actions which in turn provide feedback by the LCD or buzzer. This diagram helped us understand the overall flow before coding. And this is the PICSIMLAB development board. This slide shows the actual virtual board layout in PICSIMLAB. All components like VLCD, fan, buzzer, and switches are placed on the board. When we upload the hex file and press the switches, we can see the actual motor spinning and LCD displaying messages. It's a good way to visualize the embedded application without physically connecting any components. And finally, conclusion. This project gave us strong hands-on experience with embedded system development, from writing C code, simulating it, testing it, and debugging it in a safe environment. It improved our understanding of how microcontrollers control appliances like washing machines and how to apply interrupts, timers, and user inputs efficiently. That's all from my side. Thank you for listening patiently. Now my teammate will walk you through the actual simulation and the working code of our project. Thank you.
Hi, I am Jay Shankar. I am going to show the simulation of the project we have built in the internship program. in the embedded systems in EMERTXE information technologies. This is the MPLAB XIDE. The header files that are required for the project are included in the header files, and the source files that are required for the project are included in the source files folder. And this is the main program. The header files that are required are dcd.h, digitalkeypad.h, main.h, timers.h, washing machine header file.h. The source files are dcd.c, digitalkeypad.c, isr.c, main.c, timers.c. We have created a washing machine function definition here. The code that are required for the simulation of the project are included here. To run the program, you have to click on the build main project. Here we can see build successful and the hex file has been generated. To view the project simulation, we have to open the PICSIMLAB, and this is the interface of the PICSIMLAB. We can see the display, and to load the hex file we have to click on the file and load hex. And the board, to select the board we have PIC Genius board and the microcontroller PIC16F77A microcontroller, and the clock frequency we have used in the project is 20 MHz, and the display is 16:4 display, and we have the buttons to control, and the RB4, that is switch 5. To turn on the project we have to click on the project. We can see on the LCD display powering on washing machine. There are various options in the washing program. There are daily. To navigate the options we have to click on the button RB3. The options heavy, delicates, whites, stain wash, eco cottons, woolens, bed sheets, rinse plus dry, dry only, wash only, aqua store, and daily. To select the option we have to long press the key. I have selected heavy here. After long pressing the key, it shows the water level. To select it, it navigates where 5 options are in the water level: auto, medium, high, max, low. We have selecting the max. To long pressing it, there are 2 options, S5 and S6, switch 5 and 6, to start the program or stop the program. Clicking on the switch 5 to start the program. Program function, here we can see on the LCD display the program has been started. The timer is also on the LCD display. The function is for wash, and the fan started rotating and the function is on. Here it displays the time. To stop the program we click on the 6 to pause. The fan stopped its rotating. To resume the function we click on the RB4. The fan again started rotating. You can see here 2 options. To create an interrupt we click on the input. It shows that door is open, please close door. The fan stopped rotating. The function changed to rinse here, and the timer is as it is. After the rinse it changes to the option spin. its changes to spin. After it completed, it shows program completed, remove cloths. Again we are navigating to washing program. On clicking the buttons, we can select the options. There is a washing program showing heavy, delicates and whites. On clicking RB3 and RB4, on long pressing the RB3, we can change the specification, that is it changes to the water level. And again pressing, we can see that start or stop here. We can also see and select the program. This is the overall simulation of the project. Thank you, EMERTXE, for providing the